Hi folks, this is Nat, and this is going to be a video lesson on solving equations with more than one step. We focused in our last video lesson on sort of the basics of equation solving, things like doing the opposite, balancing the equation, and all the things about like how we show our work. And those are still going to apply, but we're going to go one step further and start talking about, well, what happens when there's more than one thing happening to a variable? Here's a quick example. I have 125 equals 3m plus 2. If it'd help you, I know that having the variable on the right side of the equation sometimes is confusing for kids, and you're more than welcome, if you'd like to rewrite it where the variable is on the other side. So if 125 equals 3m plus 2, then 3m plus 2 must also equal 125. It doesn't really matter, and we ultimately want to get used to the fact that we'll see equations with variables on either side or later on both. But if for now it makes you more comfortable, feel free to rewrite the equation if you would rather. What makes this equation a little more challenging to solve than the last ones we've been doing in the previous video lesson is that when I look at m, there's not just one thing happening to it. If I look, it looks like one thing that's happening is I'm multiplying it by 3. That's what the 3m means. So m is being multiplied by 3. And again, I could rewrite that. I could say it's m times 3 plus 2, if that would make life easier for me. But I am definitely multiplying the m by 3. The other thing I'm doing to it is I'm adding 2. So two things are happening, which means that we need to undo both of those. And this is where kids sometimes get themselves into a little bit of trouble. Because unlike one-step equations, where there's not really any thinking about it, the order that you undo things in is incredibly important for two-step equations. It's going to be the difference between correctly solving the equation and incorrectly solving it. And making the right decision about which thing to undo first is going to rely a lot on our knowledge of something we've talked about before, which is order of operations. When I think about what's happened to the m, it will have happened according to order of operations. So let's think about what's happened to this m. There are no parentheses, so I didn't do anything there. There's no exponent, so I never did anything like that to it. The first thing I'm going to come to is multiplication and division, and for a while this is probably going to be the case. We don't have to get into super complex things. But I multiplied it by 3 first. Then we come down a little bit further to addition and subtraction, and it looks like I added 2. Those are the things I've done to m. When I go to undo those things, just like with a code or a cipher, I don't redo them in the same order, I undo them in reverse. And this is the real trick with solving multi-step equations, is we're always going to be working through order of operations backwards. So not undoing things in the same order we did them, but undoing them in the opposite direction. So I'll actually start by undoing my plus 2, because that was the last thing done. It'll be the first thing undone. So I come over to my 3m plus 2. I want to undo that plus 2 by doing, again, just like last time, the opposite. That part hasn't changed. And because I want to keep the equation in balance, I'll undo it from both sides of that equals sign. One thing I don't think I talked about last time, I'll talk about now, is that it's sometimes nice to draw a line down the middle that helps of the equals sign. That'll help me say whether I've undone things on both sides, because I'll see that I've got one on one side, one on the other, which is really what you should see. But I've undone now my minus 2, and let's think about that. Plus 2 minus 2, those are going to go away. That accounts for where that plus 2 went. The remaining part is 3m, 3 times m. And over here, 125 minus 2 is 123. And that equals 3m still. So I've accounted for what happened to the plus 2, and again, I'm kind of going through that order of operations. I've taken care of the addition and the subtraction. Now I'm going to move on to the multiplication division, and I see I'm still multiplying by 3. The way I undo multiplying by 3 is by doing the opposite, so I'll divide by 3, and again, to maintain the balance of my equation, I'll do it on both sides. So the times 3 and divided by 3 cancel each other out. That's gone. I've eliminated it, and my m is now by itself. That's the goal. Remember, we're trying to clear out everything except for the variable, just like in the game Dragon Box. And that's going to equal 123 divided by 3, which is 41. So m must have a value of 41. Again, I'm going to come back probably and check, does that work? 3 times 41 for m plus 2, following order of operations. Does that equal 125? Well, 3 times 41 is 123, plus 2 does indeed make 125, so I'm good. I've checked my answer. Let's renote a couple things. 1, when I do something, I'm always doing the opposite. So we look at plus 2, I did the opposite, minus 2. Times 3, we did the opposite, divided by 3. And when we do things that are opposites, we cross them out, and we make sure that we do them not just on one side of the equation, but both sides of the equation in order to maintain that balance. Here we have another equation. We're going to go through this again, probably a little bit faster this time. But I see a few things happening. First off, I see that y is being divided by 8 and subtracted by 27. Again, I always start with that variable. The y is the most important thing in the equation. We want to find it and think what's happening to it. And it looks like, if I think about my order of operations, I am dividing it by 8 first, and then subtracting 27. Again, when I go to solve it, this is my plan, I'm going to reverse that order of operations and undo those things. So I begin by looking at this minus 27 and undoing that first. The opposite of subtracting 27 is adding 27. And I can eliminate that minus 27 by adding 27 to both sides. Again, maintaining my balance by adding the same thing to both sides in this case. So my minus 27 and my plus 27 go away. That leaves me with y divided by 8 equals 3 plus 27, 30. Next, I'm moving on to my multiplication division. I see that I'm dividing by 8. The opposite is going to be to multiply by 8. So I'm going to multiply by 8 in order to undo the dividing by 8. And since I want to maintain a balance in my equation, I'm going to multiply by 8 on the other side of the equals sign as well. So y is now by itself. Again, that's the goal of any equation, get the variable by itself. And 30 times 8 is going to be 240. I can once again, if I'd like to, check that equation by plugging that in for y. 240 divided by 8 minus 27 should equal 3. So let's think. 240 divided by 8 is going to be 30. And then if I subtract 27, I do get 3. So I know that my answer is correct. This isn't going to come up quite as much, but let's do one where we do have a parenthesis, because it does happen. Let's say in parentheses 9 plus m times 4 equals 128. Well, as always, I'm going to be coming back to that idea of order of operations and kind of thinking about what has happened and in what order. Well, it looks like, unlike my last ones, because I have a parenthesis here, the first thing I did to m was add 9 in parentheses. Afterwards, I multiplied by 4. So if I follow order of operations, first I added 9, then I multiplied by 4. Opposite of what's normal. That's okay. Still though, I'm going to do this in reverse. I got to back it up in the opposite way. So I'm going to undo my multiplication and division first this time before I do my addition and subtraction, because the addition and subtraction was in the parentheses. So I'll divide by 4 to cancel out the multiplication by 4. Again, doing it on both sides. We want to see what happened to maintain the balance of the equation. I'm going to rewrite the whole thing. 9 plus m. If I want to, I can leave it in those parentheses. It doesn't really matter. And that's going to equal 128 divided by 4, which is 32. Now I get to my parentheses. I was adding 9, so the opposite of adding 9 is going to be subtracting 9. So got to do that. Minus 9, both sides of the equation. These cancel. M is now by itself. Again, my goal. 32 minus 9 is going to be 23. So M should equal 23. And if I'm being really thoughtful, I'll go check it. I'll say, well, 9 plus 23 in parentheses times 4 should equal 128. I can go through that process again and say, yes, it does. So M must then be 23. So as you think about solving some of these multi-step equations for yourself, some things I'd encourage you to do is make yourself, just kind of like I did, this little guide. We know the order that things happen in, so if we identify what's happened and think about reversing that and doing the opposite, it shouldn't really be hard to figure out what you need to do when. When students don't think about order of operations, however, it's really easy to mess this stuff up because, if there's two things happening, you might have a 50% chance of doing it correctly if you're just kind of, taking a guess. But order of operations, specifically reversing order of operations when solving equations, can be a really handy guide to figure out when to do what. The other thing I'm going to say is that the stuff that I'm doing here, showing your work, is becoming more and more important. In a two-step equation, it really explains where everything went and helps keep our work organized. It becomes even more important the more steps that our equation might end up having. So following this good notation stuff that we talked about last time is a really essential thing the more complicated equations become in staying organized and getting the right answer. And here are your practice problems for you. For each of these, there's only 2. You need to solve the equation. It's going to involve rewriting it somewhere because you're going to need more space than what's here. But you need to show all your steps. So every single thing you do with clear work. So I want to see the same thing on both sides of the equation when you make a change to the equation. Keep those equations balanced. Want to see opposites. But definitely all that work needs to be on there because one of the things I hope you're beginning to understand is how important organized work is. Good luck.